So if we have the right angle triangle with this sides, okay, Pythagoras is saying that the square of the longer side, which is the hypotenuse, is equal to the sum of the squares of the other two sides. So a squared plus b squared. And this is what we are referring to as the Pythagoras theorem. Let's look at how we the physics people apply this concept in mathematics. An example is what I've put on the board, that two forces of magnitudes, we have two forces of magnitudes, 4 Newton and 3 Newton respectively, are acting perpendicularly to each other. So the two forces of this magnitude act perpendicularly to each other. The instruction is that find A, the magnitude of the resultant force or the resultant, and B, the angle between the 3 Newton force and the third force. We are to determine the third force. The third force becomes the resultant force. Okay, I will explain to you what we mean by resultant. So the third force becomes the resultant force. Then after identifying the third force, we are asked to determine the angle between that third force and then the 3 Newton force. So let's look at how we will go about the first question in determining the resultant force. So we have to put the information into drawing first and foremost. Now we have two forces, 3 Newton and 4 Newton. The relationship between the two forces is such that they are acting perpendicularly to each other. So if this is the adjacent, 4 Newton, to locate the opposite or the vertical force, you measure an angle of 90 degrees. So this becomes that perpendicular relationship the question talked about. Then we have the adjacent, 3 Newton. Yes, you are not wrong if you bring 3 Newton here and then bring the 4 Newton at the other side. Okay. So
yes, please.
So this is the relationship the question talked about. Then how do we identify the third force? The third force obviously will become the resultant force, which will act diagonally to the first, the two forces. It will act diagonally to the two forces in this direction. So what it means is that we have a kind of right-angled triangle. Okay, I'm not giving you this because in fact it has to take us through another concept before you vectors, before you understand, right? So we'll get there. We'll get there. Now, from equal vectors point of view, if this is 3 Newton, then we can draw another vector on the 4 equal vector on the 4 Newton force, and this side will also be 3 Newton. So looking at the direction, this plus this will give us the resultant. Okay, so this becomes the third force, or the third force whose magnitude is the same as the combined magnitude of the two. Please, are we okay?
No, please.
No, please.
No, please. No, please.
You see, we have
No, please.
all right. Hold on.
Mr.
I get your point.
Mr. We cannot see the board is not clear.
It's not clear.
Yes, please. Yes, please.
Why is it blurry?
Yes,
Please,
please.
your marker is very
Tell
light.
us when you have the diagram.
It's very light.
The light around is so much. Okay, then let me. Is it the left hand side or the right hand side? Is it this side or this side?
The right hand side.
The right hand side.
The right hand side.
The
right hand side.
Okay, then let me bring the diagram to this side rather.
Thank you.
So we have these two forces, 4 Newton and then the 3 Newton. The relationship between them is 90. They're acting perpendicularly. Please mute yourselves, okay? So we put any of them, either the 3 Newton or the 4 Newton on the x-axis. 3 Newton. Now the angle between them is 90. So by locating this vector, we measure an angle of 90 degrees to locate the other one. And this is 4 Newton. So we've had that the relationship between the two forces. Okay. Now, how do we get the third force? Once the two forces relate in this manner, okay, the third force can be obtained when we have what we call equal vectors, okay? And I'm not taking you through vectors because we haven't done it. It will take us another time. But the resultant of this and this will act along the diagonal, okay? Will act along the diagonal. Now we can bring this vector 4 Newton and then place it on this vector 3 Newton by equal vector approach. So we want to create an equal vector of this 4 Newton and place it on the 3 Newton. And that is what I've done here. So vectors are said to be equal when they have the same magnitude. So if this is 4 Newton, I have to measure 4 Newton here. When they have the same direction, you see the direction of this is going upwardly. This also would have to go upwardly, and the two must be parallel. Now, when you have this, what you have here is the same as what we have here. So this is also 4 Newton. Is that okay?
Yes.
And they are perpendicular. Now you see what we've had. We've had a right, by going through this method, we've had a right angle triangle. And now we can confidently apply Pythagoras theorem. That, oh, okay. Then if we square this, if we square the unknown, let's represent the unknown by the letter C. If we square the unknown, C squared, it should be equal to the square, the sum of the square of the other two sides. So 3 squared plus 4 squared. And this 3 squared is 9, 4 squared is 16. Okay, so it implies that C squared will be equal to 9 plus 16, which is 9 plus 16 is
25.
Oh,
25.
all right. How do we determine C? How do we determine C?
We square root both of them.
We take the square root of both sides of the equation. So square root of this side, and then square root of this other side. And C is equal to 5 Newton. Okay. And C becomes what we call as the resultant force. C becomes the resultant force. Please, are we okay?
Yes, please.
Yes, please. Yes.
Now, the question is, what is a resultant force? I want to pick the view of any of you. What is a resultant force?
Yes, please.
Yes. Can somebody share what you make of resultant force with us? What is a resultant force? It comes, okay, because of time's sake. It comes from the word result. result. You see, we have the interaction between this force and then this force. So when a force of this and a force of this acts on a body, what will be the result? Is that okay? The resultant,
Yes, please.
the resultant force is defined as that single force, okay, that can produce the same effect, okay, as the effect produced by a number of forces. So what all that we are saying is that, you see, what 4 and 3 Newton can do, only 5 Newton can do the same thing. So that singular force, please, I hope you can see.
Yes, please.
Yes,
Yes,
No,
please.
please. No, please.
The lights are
No,
on.
please.
Oh my
Light
goodness.
rays.
Yes. Oh. Let's. I'll send the video, but let me reposition. Is it better?
Yes, please.
So that the resultant force is that singular force that can produce the same effect as the effect produced by a number of forces. So all that we are saying here is that we have 4 and 3 Newton acting on a body or at a point. Okay, what 4 and 3 can do, only 5 Newton can do the same thing. And that is why this obeys Pythagoras theorem, that when you square 5, it should be equal to the sum of the squares of 3 and then 4. Are we fine?
no,
Yes,
please.
please.
Yes, please.
So
No, please.
what 4 and 3 can do, only 5, okay, can do the effect that can be produced by 3 and 4. That is why when we square 5, it is equal to 4 squared plus 3 squared. This is the square of 4, and this is 25. This is 25. And 5 squared is 25. So you realize that the left-hand side is equal to the right-hand side. And so the 5 becomes the resultant force. So we deduce that the number 3, 4, and 5 are what? Pythagorean triplets. They are Pythagorean triplets. So if this had been in NSMQ, okay, knowing that 3, 4, and 5 are Pythagorean triplets, if you give me 4 and 3, and then you ask me to produce the third force, straight away I tell you the third force will be 5 Newton, because the person knows that these 3 numbers obeys Pythagoras theorem. All right, let's look at the B part of the question. The B part of the question demands that we find the angle between the 3 Newton force and the third force. Now we've determined the value of the third force, and it will be 5 Newton. We are to determine the angle between the 3 Newton force and then the third force. So this angle in question, it is this angle in question. Are we fine?
Yes, please.
So now The bone of contention is for us to determine this angle theta between the 3 Newton force and then the resultant force. How do we do it? Let's look at trig ratios. Let's go through trig ratios. Please, are you done writing? Are you done copying this side?
Yes, please. Yes, please. Please, we can't see the board clearly.
Yes, get you. The light around is too much. I think we have.
You're done copying.
All right. We have a lot of brightness around that, and that is affecting what you can see from the board. It's actually due to today's location of the class. Okay, so please try, and then I'll send a video so it can also help. I think going forward, you have to do something about this. Okay, so we are looking at theta, which is the angle between the forces, the 3 Newton and then the 5 Newton force. You see, we have three basic trigonometric ratios, what we call as trig ratios. Okay, now the trig ratios are simply a ratio of the size of the right angle triangle. They are basically ratio of the size of the right angle triangle. So if it's about this angle, let me create another angle, alpha. So we have the angle theta and the angle alpha. Now we are looking for theta. So if it's about alpha, okay, expressing this angle in terms of the 3 sides, we can consider three basic ratios, which is the tangent of the angle, shortened as tan. We can consider the sine of the angle, shortened as sin, and the cosine of the angle, shortened as cos theta. And it's theta because the angle in question is theta, right? So if it's about the tangent of the angle theta, what is tangent? The tangent of an angle is the ratio of the opposite side to the adjacent. The ratio of the opposite side of the right angle triangle to the adjacent. So let's look at our diagram and identify the magnitude of the opposite side and then the adjacent. So tan theta will be equal to, what is the magnitude of the adjacent side, the opposite side of our right angle triangle? Yes. Anybody to share that with me? What is the magnitude of the opposite side of our right angle triangle on the board? Akosia, go ahead.
1 Newton.
It's 4 Newton. So 4 on tangent is opposite over adjacent. What about the adjacent? Yeah, but what is the magnitude of the adjacent?
3 Newton.
3. Good. So when you divide 4 by 3, what is the value? 4 divided by 3, 1.3.
3.
Good.
1.3.
3. Now to determine the angle theta, you take the tan inverse of this decimal value. So theta will be equal to the tan inverse of this value 1.33. Okay, how do we do that? On your calculator, press on shift, then go and look for tan. So shift, then press on tan, and then input 1.33, and you have the value given or obtained will be equal to theta, right? So do that for me. Press on shift, then you also press on tan, and then input 1.33.
53.
Go.
53.
So theta is equal to
53.061.
okay. So give me the answer to the nearest decimal place. 53.1 dp.
0.
Okay, so
53.1.
okay, point
Point
one.
1.
So it means that the angle between the 5 Newton and the 3 Newton is equal to 53.1 degree. We can use other trig ratios to obtain the same thing. Let's use sine. Let's test cos. Okay. It's unfortunate I cannot use the extreme right side of the board. I only need to use this side because of clarity. Okay, so when we use cos, the cosine of an angle, the cosine of an angle is the ratio of the adjacent side to the hypotenuse. Okay, so if you are using the cosine of that angle, then cos theta becomes, what is the adjacent here? What's the magnitude of the adjacent?
3 Newton.
3.
So the adjacent is 3 divided by the hypotenuse is 5. 3 divided by 5 is equal to 0.6, right? 0.6. Now, we are looking for the angle theta. So shift theta will be equal to, press on shift, then press on cos, then input this decimal value, and it would generate the angle for you. Theta is equal to
53.1.
so the same value as we had when tan was used. Okay. We can also use sine, and the sine of the angle is equal to, sine is opposite, the ratio of the opposites to the hypotenuse. So quickly do that, and then give me your final answer for using sine. The opposite is 4, the hypotenuse is 4. So
53.1.
so it means that if you have all the sides of the right angle triangle, you could use any of the trig ratios to determine the angle in question. And so that answers the B part of our question. Please, are we okay?
Yes, please.
We'll look at.
No, please.
Okay, so quickly let's go through what you've done so far. We have forces of magnitude 4 Newton and 3 Newton, respectively, acting perpendicularly to one another. Find A, the magnitude of the resultant, and B, the angle between the 3 Newton force and the third force, which is the resultant. So you first would have to draw, okay? We are told that we have two forces. of magnitude. One is 4 Newton, the other is 3 Newton. The angle between them is 90. So after drawing 4 Newton on the horizontal or the x-axis, measure an angle of 90 degrees and you locate the third force. The second force. Okay. So this angle between them is 90. Now, by using vectors, the resultant will act along the diagonal. And I'm not taking you through this because it also shifts our focus for today. We'll come to vectors, all right?